Alright, today we are reviewing before you take your test. Reviewing the entire chapter, so it's a lot here. So we're going to go through this pretty quickly because you should have learned it already. First, we're looking at our absolute value. We talked about our shower. Anything that goes in the shower comes out clean or positive. So a dirty 16 goes in the shower, has to come out positive or clean. Same thing with 93. 93 went in the shower clean, comes out clean, so it's still just 93. Here we have, if we just look at this on the inside, we have a -3, but then the opposite of -3 would become a positive, and then the opposite again would be a -3. Here we have the only thing that went in our shower was a -52, so that comes out clean, but then someone threw dirt on you, so again we are dirty, it's a -52. We're going to do the same thing here, but then we're going to order them from least to greatest. So starting off, let's simplify. 45 goes in the shower clean, comes out clean, but then someone threw dirt on you. Here's 12, and now we have the negative, or the opposite, so it's just -12. Here, 13 goes in the shower dirty, comes out clean, but then someone threw dirt on you, it's a -13. 33 went in the shower dirty, comes out clean. And here we have -6, but take the opposite, it's going to make a +6. So it says to write them in original form. If you don't, that's okay. However, on your MCA or your math test, they will require you to have them in original form, or you'll have to select them in original form. So first, our least is going to be the biggest negative number on our number line. So the biggest negative number I have is -45. I'm going to write it in the original form, negative absolute value of 45. Cross it off, because we've used it. The next biggest negative is -13, so write it in original form. Good. The only other negative is -12, so negative and then 12 in parentheses. Our next smallest, before we get to the largest or the greatest, is 6. So the opposite of -6, how they wrote it. And then our largest is 33, so the absolute value of 33. If you just wrote -45, -13, -12, 6, and 33, that is also technically correct. This was one of the tricky units that we did, looking at real, rational, irrational, integer, and whole numbers. Our real numbers, well, we don't have fake numbers, so they're all real. This is like a free point. Then our numbers are either rational or irrational. Easy way to tell them apart, well, most of our numbers are rational. Every fraction, every decimal, every counting number. The only time we're going to have irrational numbers is if we have pi or square roots that are not perfect squares. So our perfect squares are the ones that we highlighted on our multiplication table that went in a diagonal, like 1 times 1, 2 times 2, 3 times 3, whatever those numbers are, 4 times 4, 5 times 5. Okay? Those are the only ones that are going to be irrational, or if they have a ... which these would be if you put them in your calculator. So square root of 17. If we looked at our list, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. 17 is not on that list of perfect squares, so that's not rational. It's really one of those weird square roots. It's irrational. 3.6, not one of these. Most numbers are rational. Any decimal, any fraction, that's okay. Square root of 81, this is really a nice number, because if we continue going, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, and 9 times 9 is 81. So 81 is really just 9. Square root of 81 is just 9. That's a nice number. It's rational. It's not irrational, because that square root's a nice one. Again, any fraction is a rational number, and any counting number is also rational. So the only one there we have that's irrational is the square root of 17. Our integers, these are our counting numbers, 0, negative, or positive, that you'd see on your number line. We don't see square roots on our number line. We don't see decimals on our number line. We would see 9 on our number line. We would not see this fraction, and we would see -20. We could count to -20, counting by ones. And then last, whole numbers are just 0 and the positive counting numbers. So I would not count to negative 20 because it's negative. This one's negative. We don't count by decimals, counting by whole numbers, one by ones. Weird square roots wouldn't see that, but 9 is a positive counting number. Okay. Down here it says between which two consecutive integers, numbers that are next to each other, is the following number located. So looking at this list of perfect squares that's on our multiplication table. 17, that one was right here. 17 is really between 16, so square root of 16, and the square root of 25. Well, the square root of 16, what number multiplied by itself gives us 16? Well, 4 times 4 is 16. And then same thing with 25. 5 times 5 is 25. So your answer is somewhere between 4 and 5, if we were to plug it into our calculator. Negative square root of 55, well, 55 would be between 49 and 64, looking at your list of perfect squares. But they just both have to be negative because we're looking at a negative number. Well, I know 7 times 7 is 49, so there's negative 7. And 8 times 8 is 64, so that would be a negative 8. Use your multiplication chart to help you. On the back side are integer operations, add, subtract, multiply, and divide. Remember our words to our song, same sign, add and keep, different sign, subtract. Keep the sign of the higher number, then you'll be exact. So we have here first a negative 5 and a negative 9. These are the same signs, so we're going to add them and keep the negative sign. 9 plus 5 more should give us 14. And keep that negative sign. Same thing here, but we're going to only look at two numbers at a time. This first one is just a positive 9. Then we have the opposite of negative 7. Those two negatives make a positive. So this is a positive, and this is also a positive. Same sign. Add them up. 9 plus 7 more should give us 16. And then just bring this down, minus 10. These are different signs, positive, negative. Subtract 16 minus 10 should give you just 6. And there's more positives, so it's a positive. Same thing here, negative, and then two negatives make a positive. The opposite of a negative is a positive. So we have a positive and a negative. Okay, here we have different signs. We're really going to subtract them. 27 minus 10 will give us 17. And then keep the sign of the higher number. 27 is a positive number. It's the biggest, so it's a positive 17. Last one with adding and subtracting. This is a negative 11. This is also a negative 7. Minus 7, subtract 7. It means the same thing. Same sign. Add and keep. So 11 plus 7 more should give us 18. And keep the negative sign. Down below, here we have multiplication and division. Use your multiplication chart to help you. These are touching, we know it's multiplied. Our rules for multiply and divide are happy and grumpy people. So here we have a grumpy person and another grumpy person. They're going to get along because they're grumpy together. So find 7 on your multiplication table. Find 17. Follow to where they meet. 7 times 17 should give you 119. Here we have 3 numbers multiplied. We know they're multiplied because they're all touching. Look at just the first 2 from left to right, like the order of operations. Happy and grumpy, we know they're not going to get along. 6 times 3, find 6, find 3, follow to where they match. 6 times 3 should give you 18. And then bring this negative 11 down. It's multiplied. We know 2 grumpy people are going to get along. It's going to be a positive. So find 18, find 11, follow them to where they meet on your multiplication table, and you should get 198. If you're having trouble with that, make sure to ask so you know how to do it on your test. Then these two are division. This line means divide. So we're going to use our same multiplication table, but like we said, we're going to start with the bottom number in the basement, the denominator. Find 12. 12 might be over here somewhere. Follow it down until you see 144, and then look to the left for your answer. 12 times 12 is 144, so your answer is 12. Here we have both grumpy people, so I know our answer is going to be positive. Find 12 again, but this time only follow it to 36. And look to the left, your answer should be just a positive 3. Last couple, solving expressions and then order of operations. So evaluate the expression when g equals -5, h is -10, and j equals 7. So I know here that g and h are touching, so I know it's going to be multiplied. Don't just put them together. G is -5 times h, which is -10. And then this says minus from the equation right here, and then j is 7. So we are following the order of operations. There's no parentheses, there's no exponents, but we do have multiplication. So let's multiply. Two grumpy people, they'll get along, so I know it's a positive. 5 times 10 is 50. And then we just have addition and subtraction. So we have a positive 50 and a -7, different sign, subtract. 50 minus 7, well, I'm going to borrow. 10 minus 7 is 3. So our answer is 43. More positive, so it's positive. Same thing here. G is a -5. This is where we need to be really careful. Then there's a minus sign from the equation. Then h is also a -10. Another minus sign from the equation. Another h, another -10. And it's touching the j, so multiplied by j, and j is 7. So I'm going to simplify this here. The opposite of a negative we know is going to make a positive. Same thing here. Two negatives make a positive. So order of operation, we have multiplication. So 10 times 7 is 70. Just write out the rest. I just brought it down. Then all we have is addition and subtraction. Just go from left to right. -5 and a positive 10. Different sign, subtract. 10 minus 5 is 5, and there's more positives. And then last, 5 plus 70 is 75. This last one, be careful here too. This is just like these two, and these are touching, that's multiply. These are touching, that's multiplied. So we have -5 times the square root of x, and x is really 121. And then -2. So look at your multiplication table. 121 should be one of those ones that you highlighted. 121, well, 11 times 11 is 121. So the square root of 121 is just 11. So order of operations still. Multiplication and division first here. 5 times 11 is 55, but they don't get along, negative, positive, so they're grumpy still. And then -2, well, negative and another negative, same sign, add and keep. So 55 plus 2 is just going to be 57. However, keep the negative sign because they're all negatives. Alright, make sure you study up and get ready for your test.